Today we're going to look at vectors as forces. And as we begin looking at vectors as forces, I would like you to read the first page of your printout where it describes what forces are and the topic of state of equilibrium and just the vectors themselves. So since you've now read about forces and our components and our vectors, we're going to go strictly to looking at some examples to get a true understanding of what a force is and how it works with using vectors and as well as using trigonometry. So our first example here, Shamal is towing his friend Hamid on a toboggan using a rope which makes an angle of 25 degrees with the ground. If Shamal is pulling with a force of 50 newtons, what horizontal force is being exerted? So here we want to actually find our horizontal force. So we can actually go ahead and label what we know. So we know here that this is 25 degrees. We assume that this creates a 90-degree triangle. And since Shamal is towing his friend on the toboggan, and he's using a rope that makes this angle, we're talking about this here, this force here, which is actually given to us as 50 newtons. Now it's asking for the horizontal force in which he's exerting on the toboggan. So here is our horizontal force, and this would be our vertical force. Not that this question is asking for our vertical force, but just to show you, we have a horizontal which we label as our vector h, and we label our vertical vector force as a vector v. And so if we're trying to find our horizontal, so here our horizontal, and we're given our 50 degrees, using our trigonometry, and this just goes back to using SOHCAHTOA, if we're using our angle of 25 degrees, we can label this is our adjacent side and this is our hypotenuse side. So those are the two sides we want to use. So therefore we're going to use cosine. So we're going to do cos of 25, which is going to be equal to our horizontal force over 50. Now when we go ahead and rearrange, bring that 50 up and multiply it by our cos 25, we're going to get that our horizontal force here is 45.3 newtons. And that's all we need to do. And I'll obviously follow it up with a therefore statement. So therefore the horizontal force that he is exerting on the toboggan, I'm just going to put exerting, is 45.3 newtons. So just to note here, so I have touched on this already, however, we refer to quantities of h and v, so our vectors h and v, as the horizontal and the vertical components of the original force. So if we're talking about horizontal, you're going to be dealing with your h. If you're talking with your vertical, you're going to deal with the v. Now in our next example, Sandy and Mary are towing their friends Nicole, Smith, Taylor, Chantel, and Novak on a toboggan. Each is exerting a horizontal force of 60 newtons. Since they are walking side by side, the ropes pull to the sides and make an angle of 20 degrees with the line of motion. And we want to find the force of pulling the toboggan forward. So if this here, we are told this is 60 newtons. So they both are exerting 60 newtons of a horizontal force here. And since they are walking side by side and the ropes pull to the sides and they make an angle of 20 degrees with the line of motion. So here, this horizontal line is our line of motion. So they each are making a 20-degree angle with that. So just by our laws of adding our vectors, so we can have here, okay, this is where Sandy is. We know this is 60 newtons. And our vector for Mary, because we add it from tail to tip, right? This is Mary down here. And this is as well 60 newtons. And this here is our force. And we know that the angle, which you can see right here, is 20 degrees. And this angle as well is going to be 20 degrees. And so what is this angle here across from the force that we're going to be finding? If you figure that out, with 180 minus 20 minus 20, it's 140 degrees. So we know a side here, so we know this side, and we know this side, and we know this angle. So what trig properties or trig laws that can we use to find our force? That's right, we can use the cosine law. So we're going to find the force squared is equal to 60 squared plus 60 squared minus 2 times 60 cos 140. And from there, when we do our calculations, collect, we get that our force squared is equal to 12,715.5. Take the square root of both sides, and we get that our force is equal to 112.76 newtons. So just as a note here, we could have solved this question by finding the components of each force along the direction of travel and adding the resultants. So what I mean by that is you could have your two components, so 20 degrees, we knew this was 60 newtons, so let's just say Sandy here, and this is our first force, so our force was Sandy. And then similarly, again, you have your sorry, I should have drawn that differently so that you could visually understand it. So here, if this is your force of Mary, this is your 20 degrees, and this is your 60 newtons. So what I could do here is I have cos 20 is equal to the force of Sandy over 60, which when I redo this, calculate, I get 56.38 newtons. And therefore we know that they're going to be the same. So the force of Sandy plus the force with Mary, we add those together, so 56.38 plus 56.38, and we are going to get 112.76 newtons. So if the forces had not been equal, the angles made with the direction of travel would not have been equal. So we would have therefore had to find them out individually, couldn't just add them together. So now in example 3, if in example 2 Sandy pulls with a force of 60 newtons at an angle of 30 degrees with the horizon, what should the magnitude of the force exerted by Mary at an angle of 20 degrees be if the toboggan is to move straight forward without turning? So now, one thing that we do know, so just a little note here, horizontal forces have to be the same to keep moving forward. So that's really important to remember. So let's visually draw this. So if we have our force here by Sandy giving at 60 newtons, tells us that she's making 30-degree angle. And here we have still our 20-degree angle, okay, and this is with Mary. And this side here, okay, that's unknown, so we're going to call that x. So I could redraw this. Remember, when we're adding vectors, tip to tail, right? Okay, this is our x here. And then we're going to have this as our vertical force. We know this is 30 degrees, and we know this is 20 degrees. And this is going to be our horizontal force with Sandy. This is our horizontal force with Mary. Now, one thing is, so you can see here, I've drawn our vertical force. Now there, our vertical force with Sandy needs to be equal to the vertical force with Mary. So that's what we were talking about before. It's really important to understand that. So here, what we want to look at is first we're going to look at our horizontal force for Sandy. So we have cos 30 is equal to our horizontal force for Sandy over 60. So the horizontal force is going to be equal to 51.96 newtons. So then we can also look at our vertical force. So sine 30 is equal to our vertical force with Sandy all over 60. So therefore our vertical force is equal to 30 newtons. And since our vertical forces have to be equal, we therefore know that the vertical force with Mary is also going to be 30. So looking at that, we can use our sine law to find our x here. So sine 20 is going to be equal to the vertical force of Mary, which we know is 20, all over x here. Sorry, is 30, not 20. So sine 20 will be equal to 30 over x. When we rearrange here, we're going to get x is equal to 87.7 newtons. So therefore Mary is applying a force of 87.7 newtons. Looking at our fourth example here, a large Wendy's balloon is tethered to the top of a building by 2 guy wires attached at points 5 meters apart. Okay, so let's just draw that. So we have our balloon here. We have 2 guy wires, and they are 5 meters apart. So that's our first thing here. So these are our guy wires. If the buoyant force on the balloon is 850 newtons, so this here is 850 newtons, and the 2 guy wires make angles of 58 and 66 degrees with the horizontal. So here we have 58 degrees and we have 66 degrees, because that's with the horizontal. We want to find the tension in each of the wires. So this is going to be our tension 1, and this will be our tension 2. So we need to look at this and rearrange our actual wires to form a triangle. So what you're always trying to do is always trying to form triangles, trying to use our different laws and properties of trig. So I know that I can move up my tension 1 here. So this here is our 850 newtons. If I move my tension 1 up here, this is my tension 1 force, and my tension 2, remember when we're adding vectors, it needs to be tail to tip. So here's going to be my tension 2. So now how do I use my angles? Well, to use my angles, if I were to have drawn here a vertical line here, this would have created a 90-degree triangle. So therefore, to find that angle measurement, I would have done 90 minus 66, which gives me 24 degrees. So that there is 24 degrees. And then this angle measurement right here, okay, is found by adding our two angles that were given, 58 and 66, to give me 124 degrees. And then this angle measurement here is going to be 32 degrees, just by knowing our properties of interior angles of triangles. So now, using that information, I can see that I can use my sine law. So I'm going to take 850 over my sine 124 is equal to my tension 1 all over sine 24. I do everything, cross multiply, do the sine. I'm going to get my tension 1 is going to exert a force of 417 newtons. Similarly, to find my tension 2, 850 over sine 124 is going to be equal to my tension 2 over sine 32 in this case. So therefore, my tension 2 is going to exert a force of 543 newtons respectively. Now, in our next example here, a 20 kilogram trunk is resting on a ramp inclined at an angle of 15 degrees. So what we have here, we have this, it's 15 degrees, and we have our trunk, which is located right here. Okay? And what we're saying here, in the first part, we want to calculate the components of the force of gravity on the trunk that are parallel and perpendicular to the ramp. So here we have this force. So this is going to create a 90-degree angle. This here is our force 1, and located down here with our force 2. Alright, this here will be our force 2. So what is done here, to figure this out, what is the force due to acceleration, due to gravity, is what we do is we take our 9.8, okay, and we multiply it by 20, which gives us 196 newtons. So our force 1 is the force of the trunk sliding down the ramp, and our force 2 is the force of the trunk pressing against the ramp. So now, given that information here, we're actually just going to find our force 1 and our force 2. So we have sine 15 is equal to our force 1 over 196 newtons. So our force 1 is equal to 50.7 newtons. And then we take, for our force 2, we're actually going to use our cosine law. So cos with using SOHCAHTOA of 15 is our force 2 over 196. So therefore our force 2 is going to equal 189.32 newtons. So our biggest thing here that we need to make sure that we remember is our 9.8. And the reason we multiply it, by 20 is because our trunk is 20 kilograms. So what we do, the 9.8 is our acceleration due to gravity. So in our last example here, we want to talk about our states of equilibrium. So having a state of equilibrium is to be balanced. So what we want to do, if it's balanced, when you add the two vectors, it's going to always be greater than the third vector. So in part A here, let me change that to black. Part A, all we're going to do is we're going to add our 15 plus 18, which is going to be less than 38. But let's look at our other ones. If we add 15 plus 38, that's going to be greater than our other vector, which is 18. And then 18 plus 38 is going to be greater than 15. So because of these two here, when you add them, and they're less than 38, therefore there is no state of equilibrium. And then in B here, let's do the same. We take our 3 plus 5, which is going to be greater than 7, our 5 plus 7, which is going to be greater than 3, and our 3 plus 7, which is greater than 5. So therefore, there is a state of equilibrium. So just one other property I want to just talk about is our triangle inequality, our theorem, sorry. So just make a note of this. Just when you have your triangle A, B, C, AB plus BC is going to be greater than AC. BC plus AC is going to be greater than AB. And AB plus AC is greater than BC. So this is the theorem that we use when we're talking about figuring out our state of equilibrium and whether it exists or not.